Hello, everybody. Today, thanks to Aslan Garamanov, um, I hope I am saying that name correctly, we will be going over a quadratic functions problem. Now, this problem is pretty long, and as you can see, it has 16 marks, so that means it should take about 16 minutes to do in your test. And so this is going to take a while, okay? But at the same time, we're going to go through a lot of the things that have to do with quadratic functions, and maybe even all of them, okay? So hang in there because we're going to go through pretty much everything that has to do with a quadratic function. So the problem gives us that the graph of the quadratic function is f of x blah blah blah, right? 1/2 times x minus 2 times x plus 8, and that it intersects the y-axis at 0, comma c. So for part A, we need to find the value of c. Now, we know that the point c is at 0, comma c, right? We also know that it's the y-intercept. The reason we know it's the y-intercept is, first of all, because that's what they tell us in the problem, but also, if my point is x0 and my y something, that means that at x0, it can be any one of these points, right? So because of how the function is like made, it has to be my y-intercept, right? So the first way to do this is just to plug in 0, comma c in my function and find the value of c. So if I do that here, plug in 0 for x, I get 1/2 times 0 minus 2 times 0 plus 8. So working this out a little bit, I still have the 1/2 times a negative 2 times 8. I'm going to multiply the first two together first, so that gives me negative 1, right? Because it's 2 times negative, 1/2 times negative 2 times 8. So now we know that the y-intercept, that c equals negative 8. And if c equals negative 8, then that means that the y-intercept is just about here on the point 0, comma negative 8. So for part A, we know that c equals negative 8. That is the first way to do this. The second way to do this is that we know that for all quadratic functions which have to form ax squared plus bx plus c, if I have it in this form, the number that is alone, which is actually the same c here, is always going to be my y-intercept. Why is it always going to be my y-intercept? Because if I plug in 0, comma y, forcing x to be 0 and having the same explanation that I had before, where I have to get the y-intercept because my x is 0. Just looking at its general form, we can see that a times 0 is going to give me 0. B times 0 is also 0, right? So I would end up with y equals a times 0 squared plus b times 0 plus c. And so y has to be c, okay? So when teachers and stuff tell you that, oh, the c right here is the y-intercept, that is the explanation why, okay? This is the same for y equals mx plus b. Your b is the only one without an x variable next to it. So if you plug in 0, it has to be the y-intercept. You would end up with y equals b if you make x equals 0. So the second way to do this is by working out the math and seeing what my plus c is, right? We basically want to get it into this form. Ax squared plus bx plus c, so that we can see what the c actually is, right? And so I'm going to do the 1/2 times x minus 2 first. So that would give me 1/2 x minus 1, and we are still multiplying x plus 8. And this would turn into 1 half time x gives me 1 half x squared. This here would give me plus 4x. This here would give me minus x. This here would give me minus 8. And so my f of x is 1 half x squared plus 3x minus 8. And notice, quite magically, that this minus 8 is the same c equals minus 8 here. Okay, so both of these ways work, and I put it in this form because it's going to be useful later. Okay, so both ways are plausible, and they both give you credit if you show your work. Before moving on to part B, they give us that the vertex of the function is negative 3 comma negative 12.5, and to write down the equation for the axis of symmetry of the graph. So the first question is, what the heck is vertex, and what the heck is equation for the axis of symmetry? So vertex makes reference to when you have a quadratic function like this, that is your vertex, okay? And when you have it like this is your vertex, okay? It's like the lowest or the highest point, right? And in fact, this graph on the bottom, just to make it a little more clear, it would be like that, okay? That is the vertex, the lowest point or the highest point, okay? And so a vertex can be either a minimum or a maximum, right? All minimums and all maximums are a vertex, and a vertex can be either a minimum or a maximum. It's also quite conveniently, it kind of like splits the graph in two, right? Because it is mirrored, it is reflected from one side to the next. From this point to this point, if the distance from here to here is, let's say, 2, the distance from here to here is also going to be 2. If from here to here the distance is 8, then from here to here, I know that it's not drawn to scale, but it would also be 8, okay? It splits it in half perfectly, and that is what an axis of symmetry is, okay? Because these graphs are perfectly symmetrical. They are reflected, and so your axis of symmetry would actually be what value for x gives you this black dotted line that I am drawing, right? So if I have a graph that looks like the following, like this, and I have that this value here for x is x equals 3, I'm just making, or x equals 4, I'm just making it up. My axis of symmetry would be 4, because it is right where we can make this dotted line that splits the quadratic function in 2. And so if they give us that the vertex of the function is negative 3, negative 12.5, we know that the graph is going to be like this. Right at negative 3, and very down below at negative 12.5, we're going to have something that looks like this, okay? The reason I know it's facing upwards is because, well, first of all, you can graph it, right? If you really want to, you can graph it. But perhaps more importantly, my A, which is this guy here, and when I say A, I am meaning this A, okay, what is in front of the x squared. If it is positive, that means it faces upwards. And if it's negative, that means it faces downwards. Okay? So that's why I know that the graph is going to look something like this. So the equation for the axis of symmetry of the graph, it's simply going to be negative 3. Okay? And more importantly, you have to say that it's More importantly, you have to say that it's x equals -3. And then you write a short explanation that it's because the vertex is at -3, comma, -12.5, right? So that is one way to do it. The other way to do it is by using the axis of symmetry formula. If we open up the formula booklet and look at the axis of symmetry equation, we can find -b over 2a equals x is going to be my axis of symmetry, right? And if I plug this in with with b being 3, as we can see here, and my 2a being 2 times 1/2 because of the number here, we know that this is going to give me -3 over 1, and this is simply -3, okay? So this is the second way to do it. Both work, you just have to show your work, all right? So now we will move on to part C. For part C, they give us that the equation f of x equals 12 has two solutions, and that the first solution is x equals -10. And that we should use the symmetry of the graph to show that the second solution is x equals 4. So remember how earlier I explained that if I make a y line that goes like this and cuts through both, if this guy is 2 units away from the axis of symmetry, the other guy on the other side is also going to be 2 units away, okay? Same with any other line that I might make on this graph, all right? The distance here and here are going to be the same, all right? And so we know that the first solution for part C is, because they give it to us, is -10, okay? And we have to prove that the other one is x equals 4, okay? Now, having the axis of symmetry thing in mind, if my axis of symmetry is 3, and they're telling us that my first one is -10, we have to consider, if my axis of symmetry is -3, we have to think how far away is -10 from -3, right? And so if we look at a number line, here it starts at 0. From -3 to -10, how many units do we have? We have 7 units, right? We are technically doing -7 to -3 to get to -10. And so, with the axis of symmetry in mind, I see how many units is it 7 over here. And so I would have to do -3 plus 7. The reason I'm doing 7 plus 7 and not -7 is because I am going to the right side. If I were going back, I would have to do minus, because this is, again, a number line. And I see where I end up. So -3 plus 7 gives me 4. And so writing down this 4 here, we prove that my other solution is 4, given the axis of symmetry. Okay? I guess the mathematical way to prove it would be to do something like this. Okay? You also want to put that -3 minus 7 gives you -10, right? And here with the -10 thing, you are showing this guy here, all right? So that would be part C. For part D, we need to write down the x-intercepts of the graph, right? And so, first of all, what the heck is even an x-intercept? An x-intercept is wherever on the graph that it touches the x-axis, okay? And when I say x-axis, this is just a really fancy way to say the horizontal line, okay? The guy that is in blue. So wherever it touches here, for example, like this, those would be my x-axis, okay? For the y-axis, it is wherever it touches the red line, the vertical one. So in this case, my y-axis would be this point here. All right? So if for the y-axis I am plugging in 0 for x and seeing what my y is, for my x-axis, I will plug in 0 for y and find my x-axis. So we're going to go ahead and do just that. So for the x-axis, if I'm going to plug in x comma 0, I'm going to use the form in green over here, okay? Just because I think it's a lot easier to manage. So the first way that is always going to work is that you plug in x comma 0 and you end up with this, right? And I'm going to show you this way that it takes a lot longer, but it's also more reliable because it always works. So what always works is using the quadratic formula. The quadratic formula looks like this, and it should be familiar. It is x equals negative b plus minus square root of b squared minus 4a times c divided by 2a. Okay, this is the quadratic formula, and if you plug it all in, it's always going to work. Now, what does it mean by a? What does it mean by b? What does it mean by c? Let's remember that we are dealing with a quadratic function, which has this form right here. And so all we really have to do is find out what is a, what is b, and what is c. And looking at my function here, we know that a has to be 1/2. We know that b has to be 3. And we know that c has to be -8. And although this takes a little bit to actually plug in and whatever, it is something that always works. So I go ahead and plug everything in, and we know that minus b is going to be -3, plus or minus, for b squared, we're going to have 3 squared. For minus 4ac, we have minus 4 times a, which is 1/2, times c, which is -8. And below we have 2 times 1/2, right? So we know that this is going to be -3 plus or minus 9 minus 2 times -8, right? The 2 showed up from combining these two guys, all right? That is where the 2 came from. And this is all divided by simply 1, because we have 2 times 1/2, all right? And so we keep working this out. I'm going to do it on the left side now. And we end up with -3 plus or minus 9 plus 16, because it is 2 times 8 and it's double negative, so it turns positive. All of this still divided by 1. Since it's divided by 1, I'm just not going to write it anymore, but remember that that is what we ended up with. And this ends up being -3 plus or minus square root of 25. And I can simplify this even further with -3 plus or minus 5. And so here we are at the very last step of using the quadratic formula. So you're probably wondering, what the heck do we do about the plus or minus? The reason the plus or minus is even there is because this quadratic formula is for finding the zeros of the graph, okay? And the zeros of a quadratic formula is always going to have 2, okay? Whether it's like this or like that or any other version, there's always going to be 2 zeros, okay? And so the fact that there is even the existence of a plus or minus means that we have 2 alternatives, right? We have the alternative where we have -3 plus 5, and the alternative where we have -3 minus 5, Okay, and this is what makes us have two solutions, right? X is either going to be 2 or X is going to be -8. Okay, -8 for the one on the bottom and +2 for the one on top. Notice, and this is important, not because it's plus or minus means that one answer is going to be positive and the other one's going to be negative. It just means that one is going to be more to the right and the other one's going to be more to the left. What do I mean by this? I could end up with a solution that's like this, right? And this bad boy here is more to the right than this bad boy over here, which is more to the left, okay? But in this example, they are both positive values, okay? So if you get both positive values, that can still be the right answer, all right? Do not get confused by that. But in this scenario, we have that one is indeed positive and the other one is indeed negative. This was just a mere coincidence. Do not think that the plus or minus means that one answer is going to be positive and the other one's going to be negative, because that is not always the case. Okay, this is just how the math worked out. So the answers, if my two zeros are x equals 2 and x equals -8, that means one of my zeros is 2, 0, and my other zero is going to be -8, 0. So those are the zeros for part D. The other much faster way to do this, but also a little bit more confusing, so whatever floats your boat, is to realize that if we're finding the x-intercept, right, we're finding x, 0. And if I plug in x, 0 in the formula that we have, we end up with 0 for y, 1/2 x minus 2, and x plus 8. And notice that these three things, right, the 1/2, the x minus 2, and the x plus 8, they are all being multiplied. Okay, the parentheses makes them multiply each other, right? And so the only thing that makes this whole thing make sense is for one of the parentheses to be 0. If any of these are 0, then the whole thing is 0 because they are being multiplied, right? And so you have to go through the scenarios. What if my x minus 2 is 0? What if my x plus 8 is 0? And finally, what if my 1/2 is 0, right? Now, of course, the 1/2 being 0 is never going to be true because it is a fallacy. That is like me telling you that 1 equals 0. Okay, that is just not going to happen. So we can forget about this alternative. But we have to solve the other two. Okay, we solve this guy, which gives us x equals 2, and we solve this guy, which gives us x equals -8. And notice that these are the same exact solutions that we got on the last part. And so now you're wondering, like, why didn't we do it like this in the first place if it was such a faster solution? And the reason I wanted to show you the quadratic formula, which is this guy here, is because this guy here always works. Okay, it takes longer, but it always works. And you're not always going to get a nicely made formula that is already factored, like we have here, right? It's already factored because it's already in parentheses. And I just want you to know that the reliable way to do it, okay, is the quadratic formula. The quick way is if it's already factored or if you can take the time to factor. But I know that a lot of people feel uncomfortable with factoring. So that's why I wanted to give you both options. So they both work. It's important to know how to interpret it. If I have x equals 2 here, what is the y that goes with it? Well, it's the y that I plugged in right here. So if x equals 2 on this side, that is interpreted as this, the point 2, 0. And the guy over here is interpreted as the point -8, 0. Same answers that we got using the other method. And now for part E, we have that on graph paper. We need to draw the graph of y equals f of x, which is basically telling us just to graph it. They give us the maximum and minimum for my x values, the maximum and minimum for my y values, and that 1 centimeter for the x-axis is worth 1 unit, and 1 centimeter on the y-axis is worth 2 units. And so I don't have graphing paper, but I have it nice and pretty over here. And the question is, how do you graph this, right? Because part E is worth 4 points, which is a lot. So if it's worth 4 points, you want to graph at least 4 things. All right. And so one of the things you can graph is the zeros that we just got, right? The y-intercept, which is right here, and the vertex, okay? That is already 4 things. But more importantly, the graph is asking you that 1 centimeter here is worth 1 unit, and 1 centimeter here is worth 2 units. All right, so notice how here it is increasing by much larger magnitude in the y-axis than in the x-axis, okay? So just notice that. And it's important not just to put them, but also to label them. Here we would put 2, 0. Here we would put -8, 0. Here we would put 0, -8. Here we can put z vertex, which we know is -3, -12.5. And that is how you would answer the graph part E. And so now for part F, they let us know that t is the tangent at x equals -3, and to write down the equation f of t, and to also draw the tangent t on the graph. And so first things first, what the heck? What the heck is even a tangent, right? And so a tangent is a line that touches another one in just one point. So for example, my tangent at x equals 2 would probably look something like this. I know it's not drawn perfectly, but basically it touches at x equals 2 and then never again. Now it's important to notice that it's not that it intersects it at 2, okay? Because intersect at x equals 2 could be something like this, okay? This is not a tangent because it touches twice and also it cuts through it. A tangent touches it only once and never again and does not cut through it. All right, so that is an important distinction between tangent and intersection. And so if they tell us that the tangent t is at x equals 3, we look at our graph in x equals 3, sorry, at x equals -3, and we notice that it is right here, right? And so what is my y value at x equals -3? Well, it's the same as the vertex, right? And we know that the point of the vertex, as they gave us earlier, is -3, comma, -12.5, right? And so if it touches once and never again, and it is at the minimum, and we know it is at the minimum because it is at the vertex, then we know that it has to be a straight line. Okay? This is the same as when you have a maximum and we have a tangent just at the vertex. This is also going to be a straight line. Okay? So tangents at vertices, which is either a maximum or a minimum, are always going to be flat. Okay? And how do I draw a flat line? If this point here is -12.5, then my graph for t is simply going to be y equals -12.5. Okay? I know that this, for the equation of a line, can seem really weird. And so if I tell you to graph me, for example, x equals 2, how do you think you would do that? You go at x equals 2 and you graph it right here. And you literally say that here is where x equals 2, right? If I tell you for y equals 2, how would that look like? You got the height of y equals 2 and you literally write this is where y equals 2. So that is an important distinction, all right? X equals 2 is going to be the vertical one here, and y equals 2 is going to be the horizontal one here. They are both flat, okay? I mean, the y one is flat like horizontally, and the x one is like super straight up, all right? And so if we know that the tangent is at a vertice, then we know that it has to be flat, and if it's flat, it has no slope, and so it is only going to be a constant. Okay, so that's also important in your answer to maybe write it is the constant negative 12.5. So that is the answer for part F, and here it is drawn in black. All right. It is important that when you draw it, you also literally write y equals negative 12.5. So that would be part F. Part G, they give us that f of a, which is a whole new formula, is 5.5, and the derivative of f of a is negative 6. I'm going to state whether the function f is increasing or decreasing at x equals a, and to give a reason for the answer. And so if I am told that f of a, right, is 5.5, right, and I am also told that the derivative of f of a is negative 6, and you need to state whether it's increasing or decreasing, I need to realize that when it is in the form of a derivative, these are values for rate of change. Having this in mind, we want to graph visually what both pieces of information give me, right? So I'm going to start with the one on top. So I'm just going to invent that this right here is my value of a for x, and we know that it reaches 5.5 here, right? It's going to be 1 point right there. Here I am graphing the information on top. And if I graph this information here, I know that the rate of change is negative, right? So it has to be decreasing in one way or another. Now, the function f of a, we don't know if it's quadratic, if it's linear. Dude, it could be literally anything. But we know that the rate of change is negative. And so if the rate of change is negative, that means that the slope is also negative. The rate of change is equal to slope, okay? And so the line could be like this, as it could also be like this. It could be a quadratic function that looks like that. But my whole point is that if the rate of change is negative, right, negative something, in this case negative 6, it means that right on the point A, 5.5, it is decreasing the slope at right here, this step right here, at negative 6 units, right? And so that is how you interpret this information, and we conclude that the function at A is going to be decreasing, okay? We are not sure how it looks like, but we know that it is going downward. And so that is how you answer part G. That concludes all of the parts of the problem. I feel like we went over a lot of information, so I hope it was of your help. And once again, thank you very much, Aslan Kahramanov, for making me the question. It is my pleasure to answer your questions, and if anyone else has any other ones, please let me know. Peace out.